Question number 4. Now you could see that's a very straightforward question. That is a question that has been brought from dynamics. Now let's see, what does the question say? There's a ball with speed 9 meters per second collides with another identical ball at rest. So a little bit of diagram, let's make it. So here is that ball, and okay, there's another ball, and what happens, let's try to see, okay, step by step. Now the first ball comes and hits the second ball, and the second ball is initially at rest, okay. So here is this one coming with a speed 9 meters per second. There is a mass m, identical, this is at m, and they are at rest. Now after this hits, what happens? Let's try to see the final picture of this. So the final picture is going to come something like this. Like it says the direction of each ball, okay, makes an angle of 30 degrees with the original direction. So here and here. So this angle is 30 degrees and this angle is 30 degrees. And we got to calculate. See, the question does not ask us the value of velocity. It simply asks us the ratio of velocity. Now you could see that the matter is so symmetric. If I call this velocity as v, this has to have the same magnitude v. You see, the ratio of the magnitude, that has to be same because it's symmetric. Or if you want to think in this way, imagine this is v dash, conserve momentum along y, okay. Now what is the initial momentum along y? That is 0. Why is it conserved? It's very clear, there is no external force. Now this is going to be mv sine 30 minus of mv dash sine 30. Now we are conserving momentum along y. That's what we are doing, right? And you could see that the value of v dash will be equals to v, which in any case could have been easily calculated by symmetry. So the ratio of the velocity, that's going to be 1. Now that was question number 4. Let's go to 5th question. Question number 5, that's from polarization. Now polarization is also a topic which is exclusively present only in mains and not in advanced. All right. So like electromagnetic waves, semiconductor, polarization. So specifically from these topics, the questions are highly probable. So every aspirant who are the future aspirant should take care of this thing. An unpolarized light beam is incident on the polarizer. Okay. So let me draw a polarizer. I think that will be a better way. And there's an analyzer as well. Okay, and then we just need to draw the axis there. So that's great. Now let's see. Now what does it say? An unpolarized light beam is incident on the polarizer. So if that's unpolarized, so this is how unpolarized beam would be represented. This is the direction of the wave. You get that point. And I can assume any direction through which the polarization would happen. So let me assume this. Now you could see here, if this intensity is I naught, clearly this intensity would be I naught by 2, because an unpolarized beam, when it passes through a polarizer, the intensity gets halved, right? Now after that, what does it say? The intensity of light beam emerging from the analyzer, not from the polarizer, that is 100 lumens. Now one thing is missing in the question, the relative orientation between the polarizer and the analyzer, that has not been given. So I'm just assuming in the good faith, okay, so the axis, that is same, the plane of polarization is same, so therefore this will be 100 lumen. That means this was 100 lumen, which is I naught by 2. The transmitted light of polarizer, that's 100 lumen, and that is also the transmitted intensity of analyzer. Now what does it say? If the analyzer is rotated around the horizontal axis, now this axis, it's been talking about that, by 30 degree, we need to find the new intensity. So it's quite a simple thing, the Malus law, isn't it? So this one is 100, so what do I get? The transmitted beam of the analyzer would be 100 cos squared 30. So cos 30 root 3 by 2. So this comes out to be 75 lumens. Let's go to question number 6. Question number 6. Now this is from hydrostatics. The Pascal's law would be utilized here. A hydraulic press can lift 100 kg. Okay, now what I'll do is that let me quickly draw a hydraulic press. Okay, so this is the hydraulic press. All right, you know, in a case of a hydraulic press, there are two different cross section, and in one cross section of the smaller one, the force is applied, and of the larger one, of course, you know, the one that has to be lifted, like typically this one, that has been kept here. Cool, now we have done everything. Now let's see, here's the force which is applied. All right, now what does it say? Now it says that the hydraulic press can lift 100 kg, initially 100 kg, when a mass m, so the lifting here is also done with the help of mass, not by the force which is applied, and this is m, all right. Now it can lift dash kg when the diameter of the larger is increased by 4 times. Okay, now if I call this as A2, if I call this as A1, A2, now a change will happen. The diameter becomes 4 times, so the area will be 16 times. So original area was A2, the new area would be 16 times A2. And that of the smaller is decreased by 4 times. So A1 would be A1 by 16. Cool. Now what has happened is that originally M was lifting 100 kg with the area as A1 and A2. Now with the new change, we would like to see, you know, the same mass M can lift how much of the mass here. Now, you know, the Pascal's law, the increase in pressure at one point is transmitted equally everywhere in the same direction. So the original one was what? mg by A1. That was equals to 100 g by A2. You get that? Now, in the second case, we got to find, you know, the same mass m. So in this second case, mg by A1 by 16 will be equals to, so this is the new mass that we are calculating. With the new change, the same mass would lift what amount of new mass that is there. So capital M is the unknown, and this is 16 multiplied by A2. So you can easily see, if you just divide equation 1 by equation 2, then 16 into 16, that will be 256. There is another 100 there. So you are going to get 25600, a Hughes value, 25600. And the Hughes value is easily, you know, understood. Reason being, lesser is this area, greater is this area, more favorable would it be for Pascal's law. Remember, the increase in pressure at one side is transmitted equally everywhere in a closed container.